Alright, so today I'm going to be doing problem number 102 on page 340, which is chapter 5. Now then, the problem is to prove that the function, which is the antiderivative, is equal to the integral from x to 2x of 1 over t in respect to t. And I need to prove that the 0 to infinity interval is positive. Oh, well, not positive, constant, my bad. So the first step that you have to do is use the second fundamental theorem of calculus in order to take the derivative of both sides, and taking the derivative, the antiderivative gets you to the, gets you to the original function, and that is equal to 1 over 2x times 2 minus 1 over x times 1. Now the reason that I have this times 2 and this times 1 is due to the chain rule. Since the boundaries are not like 1 or 2 or whatever, it's x and 2x, which means that I have to multiply by the derivatives of 2x, which is 2, and x, which is 1, and when I subtract them, I happen to get it equal to 0. Oh, not x equals to 0. Now then, if I want to return to the original function, which is the antiderivative of this, that would be equal to what's called 0x plus c, or more simply, just c. Now then, it would be this constant for the entirety of this function from negative infinity, to 0, not including 0, of course, because if you look at the original function 1 over t, that is a function with a vertical asymptote at x equals 0, and 0 to infinity. And of course, it just so happens that 0 to infinity is one of the intervals in which it is equal to c. And so that means that from 0 to infinity, oh, not to infinity, just 0 to infinity, the value, oh, well, whatever, f of x is equal, is equal to c, or a constant, and that's why it's proved that this is constant on the interval from 0 to infinity. And that is it for this problem. Thank you very much for your time. I'll just